Alright, science lovers, let's get straight to the heart of molecular biology today. I'm breaking down the detailed process of polymerase chain reaction, or PCR. If you've ever wondered how scientists can take just a tiny bit of DNA and make millions of copies, this is where the magic happens. PCR is like a photocopier for your genes. All you need is a DNA sample, a couple of primers, some nucleotides, and a super cool enzyme called Taq polymerase. Let's see how this all works. Step 1. Denaturation, or as I call it, the melting step. Here, I heat the reaction up to around 92 to 95 degrees Celsius. That's almost boiling hot. Why? Because I want to break the hydrogen bonds holding the two DNA strands together. The double helix melts apart, leaving me with two single strands, each ready to act as a template. And you know what's amazing? Taq polymerase, which comes from a heat-loving bacterium called Thermus aquaticus, doesn't even flinch at these high temperatures. Next comes the annealing step. Now, I cool things down to somewhere between 50 and 65 degrees Celsius. This is when I add primers, short stretches of DNA designed to match the start and end of my target sequence. These primers stick, or anneal, to their complementary spots on the single-stranded DNA. It's a bit like placing bookmarks at exactly the pages I want to copy. Without primers, Taq polymerase wouldn't know where to begin, so this step is absolutely crucial. Then I crank up the temperature to 72 degrees Celsius for the extension step. This is Taq polymerase's time to shine. Starting from each primer, the enzyme adds new DNA bases, those A's, T's, G's, and C's one after another, building up brand new strands. And just like that, I've doubled my DNA. But I'm not done yet. The real power of PCR comes from repetition. I repeat these 3 steps: denaturation, annealing, and extension again and again, usually 25 to 35 times. With every cycle, the amount of my target DNA doubles. This is exponential growth, so in less than a couple of hours, I can go from a single, tiny DNA fragment to millions of identical copies. So next time you hear about DNA fingerprinting medical diagnostics or research breakthroughs, remember, PCR is the unsung hero quietly working behind the scenes, amplifying DNA and opening up a world of possibilities for science. Thanks for tuning in. Now go out and amplify your curiosity.